A function is somewhat of a mapping. A function is somewhat of a mapping where you take one input, example, a skeleton, a mob, and a zombie, and when you pass it to a function, it returns something else. Example, for a rotten flesh, some bones and stuff. Okay, now the skeleton input gives us multiple things, while a zombie gives us only one thing. We will talk about this later. Okay, but you need to know that a function takes the input and spits an output. Okay, input output, it's like a device. Okay, a mapping. So now you got that. Let's see how our function, which type of functions do we get, because functions have types. Okay, one type of function is a one-to-one function, like how a zombie turns itself into a rotten flesh. A one-to-one function maps a specific value of x to a unique value of x to a unique value of y. Okay, so example, take the function f of x is equals to 2x. It will map every input x, example 1, 2, 3, 4, 5, into a different unique value of the other set, which is the output, or like 2, 4, 6, 8, 10, blah blah blah. Okay, so it takes the input and the values of input and maps them into a unique value to the output. Okay, that is called a one-to-one function. If we graph a one-to-one function, example, let's say 2x, x cubed, x squared, x to the 4th power, to the 4th root. Well, roots are somewhat of a dual-edged sword when you're talking about it, but yeah, for now just stick on to the positive half of the square root of the 4th root of x. Okay, so in that, those are one-to-one functions. Understood? Nice. Then there are many one-to-many functions. One-to-many, what does it mean? Example, you plug in a value, you take a skeleton and you kill it. It will give you many items. Okay, a bow, a bone, a arrow. These are many values. But here's the thing, here's the difficulty. What is the problem? How do you know what will you get when you plug in a value of x? That is why when we have a many-to-one function, those are generally considered bad. We cannot really use them because they give us, instead of a unique value, it gives us multiple values. Sometimes it may repeat the answers that it gives us. Example, a bog may give us the same stuff as a skeleton, as a stray, but it will likely be a little different. Okay, this is why one-to-many functions, are not considered. Okay, and a one-to-many function does not really exist. Okay, this is why I'm not giving any examples. It does not exist, literally. Okay, yes, you could give some, like, no, you cannot, literally, because when we, the difference between a normal function and, now I said one-to-many functions gives us multiple values. Why does it give us multiple values? Well, if we graph, let's suppose f of x being a valued function. Example, f of x is equals to 1 minus x. the square root of the quantity 1 minus x squared. That if we draw the line x is equals to 1, for example, it will give us multiple values. Okay, it will okay, that doesn't, but let's say as x is equals to a half, it will give us square root of 0.75 and negative square root of 0.75. Now we do not know if it should output a negative variant if we only wish to get the positive of the positive, only one of the solutions. So this is why it's a bit difficult. Okay, a many-to-one function, okay, is found when you are solving. Example, you solve for y in the equation, remember, not in the not as a function but like a variable. Solve for y in x squared plus y squared is equals to 1. You solve for y, you need to put a plus minus outside the square root. You need to put a plus minus outside the square root so that you know that different values of x can work. Now when different values of x can work, that means y isn't really a function, because y technically is a function. It just takes it may be like two values of x equal the same value, but it needs a plus minus. It's kind of cheating, so that's why it's not really a real function. Okay, when you think about it. Next type of functions are many-to-one. A many-to-one function, example x squared, it takes a value of x and maps it to a value of y, and the value of y it maps to maybe another value also works for that solution. Example, take the x squared. When we plug in x is equals to 2, it gives us 4, but this value of 4 also we also get this same value if we plug in x squared, because yeah, you guys can figure it out. Okay, it's not my job to teach you math. But okay, example, there are many functions, okay, many inputs I can give in terms of how I can kill this skeleton with a sword, with my damaged axe, with my not damaged axe, but it will yield the same outcome, killing that skeleton. This is a proper function. Okay, you can like this, but okay, later on we'll find inverse functions later. The inverse of this function is a many-to-one, which does not, as I before said, does not really exist, is not really a function, Okay, I think saying does not exist and not being a function, that may be confusing. Okay, I'm kind of contradicting myself. Let's define a many-to-one function properly. A many-to-one function, like, this is kind of a terrible didn't really plan this out. A many-to-one function, yes, it does take many values as the input, but we cannot determine the output. Okay, that's the only bad thing about it. Okay, when you draw the curve f of x, where f of x is a many-to-one function, okay, no, one-to-many function, one-to-many function, it will give us like for a value of x, for like a value of x, give us two solutions, two values of y, about a value above it and a value below it. Okay, and you cannot really choose which one, because it gives you both at the same time. Oh god, dude, I need to be careful. I do not need to spawn a model. Okay, so it's like kind of weird. Okay, you cannot really work with it. This is why we tend to avoid it. these types of functions. Last type is many to many. Many to many. What type of thing is the example of a many to many function? Well, the circle example I showed you earlier. Normally taking the positive root, it yields like a top half of a circle. It looks like a top half of a circle. But remember, we are solving for y, not making it be a value, a function. So it may be plus minus the square root of r squared minus x. So here y can be a different value and x can be a different value, and both will have different solutions. So like for y is equals to this, the x can be both positive r and negative r. It could output either a positive y or a negative y. Saying the positive root is the one we take as the proper origin. So like if you can see, you can also see by the graph, like for a value of x it gives us two values, for a value of y it gives us two values of x. This is called a many to many function, and this is not really a function at all. 100% not a function. This is only an equation. It is not a formal function. So that's that. Now that we know what our functions are, let's see what else can we do other than plugging in values and plugging out values. We can ask ourselves, what can we actually put and what do we expect to come out of the function? The values that we can insert is the domain, and the values that we can spit out. I was distracted. Where was I? I'm sorry. I needed to cut for a few moments. It spits out. No, it is the domain. Is like what you can give it, what you can feed the function. So example, killing a creeper. Now the valid tools that are made to kill it is the sword, the axe, a bow, a trident, a mace, other things. A crossbow. A crossbow. Now those all can be thought of as the domain. What you can input. Now and it also started to snowfall. Besides, let's not mourn our grief or that. Let's actually do some math. So in terms of normal maths, the value. Let's take a square root function for example. We can. It looks like we can input any value, but really we cannot input any value of x. Why? If we try to plug in the negative, the negatives, it will not work. Why? Because it returns a unknown value. It will return math error, because you cannot take the square root of a negative number. I'm not going to tell why, but so knowing that it cannot be negative, the domain that we write would be x greater than 0. The values of x must be greater than 0, greater than or equal to, because 0 does work at least. But we know it should never be negative. Negative numbers are less than 0, so that's why we define it as less than equals to 0. Now, for defining what the range is, okay, now we told ourselves that we should never plug in a negative, else it will give us a math error. Okay, make us leave the lead. Now, what kind of what values should we expect from this square root function if we cannot plug in everything? Well, the values we expect is the range. Okay, the range of values that we expect it to give us is a range. Example, that skeleton, we expect it to give us its armor, its the hand, what it occupied in its hand, the bones, the arrows, and the bow. Okay, this is the range of the skeleton. What would be the range of the square root function? Well, if we cannot go the lowest value that we can input in x is 0. So logically the function should output more than 0. So the range would be x is greater than equal to 0. Yes, this does work for only a simple function like square root of x. What when we look at polynomials? Okay, polynomials. Example, x squared plus ax squared plus bx squared plus c. When we have example, if we plug in a graph of x squared plus 2x plus 2. Now this is flying. Okay, you can input any value of x and it will give you something. But to what extent is that something limited to? Okay, well, if we draw it out using our minds, then we will see that it cannot give us a value greater than 2 and greater than 1, less than 1. So we say that it is less than 1. But how do we actually find it under exam pressure? Okay, how do you find it under exam pressure? Well, this is the fun bit. You do not find the value of you do not find the range of a function under exam pressure. We find the domain of the inverse of the function under exam pressure. Now, what on earth is the inverse of a function? Well, you know how a function maps a value of input to a value of output. The inverse function does the reverse action. It maps the output to the input back. Now, to take the inverse, we solve for x algebraically and express it in terms of f of x or y, as you may do it. In my notes, I have given you the example on how we can solve it. We replace f of x with y and x remains the same. We solve for x, isolate x and express x as in terms of y, and then we replace y with x and x with inverse of x. This is how you can find the inverse of any function. Just you need to know the algebra. Okay. Now you found the function, you have the inverse, you have the function. How do you know the range of a function now? Well, you find the domain of the inverse of function. Why does that work? Well, if you see from the thing I said, then you see that the range of a normal of the function is the same as the domain of the inverse of function. You get me? I hope that makes sense. The whatever it spits out, that's the same thing that the inverse function you can feed. Okay, whatever it spits out, it is the same thing you can feed in inverse. Okay, and whatever the inverse spits out is whatever you can feed the normal function. Very easy, I know. Thank you. With all that said, what does this okay, now we know what an inverse is. We know types of functions. Shouldn't we know what happens to each function type when we try to find its inverse, or if we can find its inverse? Yes, a one-to-one function becomes a one-to-one function. Okay, take the example y is equal to square root of no. Yeah. Let's take that for example. Take for example y is equals to square root of x. Now the output is the square root of x, and the input is x. You find the inverse. Okay, the inverse of this function would be x squared. The values that you input into x squared would be what? Square roots of x. Okay, the output of our normal function would be the input of our inverse of function. And if okay, but knowing this, what should the inverse of the function give us? Yes, x. Which x? The x that we input into the function, into the normal function. It all makes sense now, does it? Now for one-to-many, when a function gives us many values, the input will take many values and give us one singular value. Okay, now I said one-to-many functions is kind of cheating because it uses two branches. Okay, a plus and a minus. So really, the only time you would have to use this is for integration, but that's for another video, So a one-to-many function, the inverse would become many-to-one. Okay, a many-to-one function is an actual function, but a one-to-many function is like a fake function. Okay, next is many-to-one. It takes in many values, it spits out only one value. Now many-to-one, yeah, that is a function. Okay, like example x squared, and it gives us one-to-many. Okay, example x squared, the inverse would be plus minus the square root of x. Now this plus minus is what makes this inverse like a cheating function. Okay, not really a function. Okay, so that's that. Next is many-to-many. Now, like I said, many-to-many is not a function, it's an expression. But if we wish to solve a many-to-many function, it will give us a many-to-many function. Okay, it's like, okay, as you can see in the with my voice, okay, not with the diagram. Okay, normally I would be on my notes app and explaining this, but it just switches the words. Okay, one-to-many, many-to-one, yeah, sure. Okay, wow, you notice that, mashallah. Okay, so that's the gist of it. What the dude? Oh my god, I'm being shot down because I'm teaching maths in broad daylight. What a crime am I doing? Look, there's a creeper trying to blow us up. But yeah, that's the gist of it. Now, so knowing that to find the range, we find the domain of the inverse. This can be applied on the reverse. If we wish to find the range of the inverse of function, we find the domain of the normal function. Okay, all good? All good. Third part finally is finding the composite function. What is a composite function? A composite function is basically like you are applying two functions at once. Okay, let's take a function f and a function g. Okay, remember, the variables that you assign a function is the same as the name you assign to your baby. Okay, it can be anything. Okay, not literally, but it can be anything logical. Okay, so one is F and one is G. Okay, it's like a trio: F, G, H, K, M, and whatever. Okay, that's F and G. That's a perfect duo. Okay, now if we do if we apply F and G together, okay, together as in we apply G first and then F later, okay, F on top of it, that is a composite function of F and G. It is not commutative. Okay, if we wish to do G of F of X, it is not the same as doing F of G of X. Why? Let F of X be 2x and x and G of X be x squared. If we plug in 2 in the composite function F of G of X, then we get 2 times 2 squared, which is 2 squared is 4, and 4 squared and 4 times 2 is 8. Now this will give us a nice thing. Oh no. Oh, sorry. This is that I'm running away. I need to be careful of my meter. I need to heal. Okay. Now, okay. Yeah, now for the G of X. So if we do G of X, so 2 times 2 is 4. 4 squared is 16. Notice how they do not give us the same value. One gives us 8, one gives us 16. Who should we listen to? You should listen to no one. Okay. Yes, you should listen to your parents, but not these two. Okay. If we see that the order changes the value, this means that the order is not commutative. Commutative means you cannot switch the order. Like in addition and multiplication we can, but not in subtraction. Okay, so that's that. Okay, that's an example for it. So that's one of the examples you can have of composite functions. Composite functions can also be with the same function. Example, f of x. Now it will give us 2 times 4x and 2 times 2x, 4x. This composite function of the same function gives us another function. Example, u of x, and the composite function of g of x would yield x to the 4th power. Okay, which we call it v of x. And you can create infinitely many composite functions using this. But we only have 2. Okay, composite function only goes up to two functions chained together. Okay, in the syllabus. Okay, I wish it was more. Oh no, let's not wish it was more. It would be hell. Yeah. Final thing. Okay, final thing before I end this suffering is the composite of a function and its inverse. What is that? You know how when we solve questions in algebra, we tend to apply the opposite. You know, and for an x squared, if we want to remove it, we do square root of an square root, we square it. And this is the same principle. When we apply the inverse of a function to the function, it will give us the input. It will yield an x. Similarly, if we apply the function to its inverse, it will yield us x also. So we know the composite of a function and its inverse always yields x. Always, 100%, no doubt. Okay, without any shadow of doubt. Okay. Now this is useful for if you are a 0580 and get a question like find 5 f of x is equal to 4, where f of x is a exponential function. Example 5 to the x. Now you do not know what on earth x could be. You know this rule of composite and composite of f and f inverse give us x. So you apply f inverse on both sides. Okay, this is a really bad example, but you see, one of the sides would be x, the other side would be f inverse of 4. Now this is a very stupid example. Okay, let's say f inverse was 4. So if we apply f on both sides, you would get x is equal to f of 4. F of 4, which evaluates to 5 to the 4th power, which is 3125. Yeah, 3125. So this could help us in avoiding the case of computing the inverse of a function by not even wanting to use the inverse in the first place. Okay, it's a cancelling but with extra steps. Okay, I hope you like this video, like the gameplay I'm doing. Okay, yeah, and this is on the igcse server. Do not worry, this is nothing different. Okay, so bye.